Today topic, function of cathode ray oscilloscope, that is CRO. That cathode ray oscilloscope is a multi-purpose display. This is the observation, measurement, analysis of waveforms, that is a floating time aligned with the x-axis, voltage is aligned with the y-axis. So what is the CRO? The CRO, cathode ray oscilloscope, you are using the electronic test instrument. This is you are using the different type of waveforms your observation, that is for example sinusoidal wave, square wave, rectangular wave, the triangular waves, that is your observation. This is the using the CRO. So you see this CRO, so this you see this CRO, this is the channel 1, this is the channel 2, this channel 1 and channel 2, this is the knob buttons. So first is channel 1, channel 2 is you are given here. This is the channel 1, channel 2 dual. So you connected these buttons, you see here, these buttons totally, this is the channel 1 position changes. So for example, this is another one is, this is the channel 2 positions. Okay. So here tread level, position and variables, here time for division, this is the time for division button. Here is voltage button both. So voltage button means both wire given here. This is the channel 1, for example you connected the probe here. So you waveform, this is the display, for example this is the waveform. Okay, you waveform displays the screen. So this is for example sinusoidal waveform, this is the sinusoidal waveform. So this waveform your output coming here, you connected this probe is this side. Okay, so only you change these buttons only, don't change these buttons. Okay, so for example probe you connected here, the select button is channel 1, this button is selected. Okay, for example channel 2 connect probe connected this side, you change here this button, you select to channel 2 here. Okay, for example you additional probe, additional button probe. So for example additional probe you given the another one this. Okay, so that is you select the this button, you dual. So both connections your output is the display, waveform is observation the screen. Okay, so here different buttons there. This is the intensity, this is the focus, these are different positions. For example this wave up or down, you change this button, this wave is the up and down button, this change is the this position button. Okay, so only you change the channel 1 button. So for example this wave is small size, this wave is the small size or bit size, you change in that. Here given the here h1 and h5, so that is the wave is 1:5 ratio, you changes that. Okay, so both we are using this button only, here h1 and h5. For example wave is very big, bit is came this one, so you change that one. Here you are given h5 and h10, so this is also wave is the output 5:10 ratio is came in that one. So here this button universal position and normal position, here also up down position, here this is the left and right side position. For example wave, this is a wave, this wave is only your observation value is the time for division or voltage values, both value any value, your output this speed point to this point. Okay, this is exactly your observation, this screen, this is the y-axis, this is the x-axis, exactly coincide this waveform here. For example you take the x-axis, this is the time, your y-axis is the voltage. So we will find out the value, for example your frequency. So frequency value, this waveform we origin this angle to, this is the 180 degrees, another one is 180 degrees, totally how many degrees? Totally 360 degrees. So 360 degrees is the waveform, this speed point to this speed point you are observe noted values. So that how to you are measure that. So here you see this is the origin point, here to here this line is a 5 divisions is there. So each division 0.2. So how many division? Totally 5. So the total is 1 unit. So that is you are calculate that how many divisions is that coincide the wave. Okay. So for example this point to this point, how many units there? That value into you take the time for division. So you see here time for division means this is the seconds, milliseconds, this line, small line is there. This small lines to this small lines is the middle value, so total is milliseconds. This is the microseconds. So this red mark, pink mark, this is a very coincide you are exactly you are observation that. So for example, this is the 0.2, this is the 0.5, 2, 5, 10, 20, etc. This is the numbers there. So for example, here waveform this peak point to this point to, for example, 3.2 centimeters or 3.22 centimeters into this value noted. Okay, how much is the time for example 0.2, that value multiply the, you calculate the time for division. Okay, so at the same time this is the only find out the only time period. At the same time you find out the voltage. Voltage is also you are observe here. This is the voltage, you calculate this point. This is the voltage. This line is time period. This is the voltage. So where is the voltage? This one. Here is also same 180 degrees angle. Another one is also 180 degrees angle. This is also totally is 360 degrees angle. This scale you take that. Voltage value is this line. So 1, 2, 3, etc. The same time here is also 1, 2, 3. So where is coincide these lines, that is the units. So how many units that value into time for voltage, don't take the time values there, only if observation value x axis value into time, here y axis value into voltage, that is the concept of the this value. Okay, your observation the waveform. So first this is the block diagram of the CRO. Here different values there here. This is the vertical amplifier, horizontal amplifier, synchronization amplifier, sawtooth swim generator, band in circuit. Next to DC power supply, this one. This is the different this is a briefly I am explaining after. So first so this is the cathode ray oscilloscope of vertical amplifier, horizontal amplifier, trigger circuit, sweep generator, CRT and power supplies. So okay, so here horizontal control is you are observe this, horizontal control is only you are observe this line. Okay, means sinusoidal wave, the find out the time values. For example, vertical amplifier is also same, you are take the y axis scale. So you see the here horizontal control and vertical control this. Here volt for division, I am already telling this. Here time for division, position knob and dual mode. So this is the vertical control and volt for divisions and time for division, position on knob and dual mode is here. This is the CRO you are observe once again. This is the volt for division mean this. Okay, here 0.1, 0.2, 0.5, 1, 2, 3 this etc. This is the voltage 1, another one is also voltage 2. This is the volt for divisions. So here time for division mean this button. Here I am already telling this one. The knob mean trig level mean this button. Trig level mean for example this wave blinking. This wave is the blinking, for example is the blinking. You change this button, trig level button you change the exactly coincide the zero. Okay. So for example position is also here this is the position, you change the left side or right side is a wave, that is the observation, the change this button is moving this side, only this one, position of that one. Okay. Next dual mode. Mode mean that is channel 1, channel 2 both value output is displayed same. Okay. So here oscilloscope has capability up to display both channel signals in the on the screen at the same time. Okay. So that is the value. Next intensity control and focus control, that this is also same, you are observe CRO. This is the intensity, this is the focus. The intensity control you are using, wavelength is brightness, focus is use the sharpness, sharpness of the waveform. This is a trace control is the your CRO screen, that is a trace level. E calibration buttons, that is the here is also same multiple channels display, alternative or chop. The alternative chop mean multiple mean this is CRO, this channel 1, channel 2 and channel 3 here etc. Anyone you are given is a changes these buttons there. This is the AC turn automatic, and this one you always this button you are select the alternate automatic. Here is also once again this one, here AC, ground, DC this channel. Another one is also AC, ground, DC. These buttons, both buttons, channel 1 and channel 2 and channel 3 also, you always you select that one AC, you select always AC, don't use the ground. So this is the calibration of the point, that is the alternative process. How to the construction of the cathode ray oscilloscope? The construction of the oscilloscope is different types of the names. Already this is the CRT. CRT means cathode ray tube. Cathode ray tube. EGA mean electronic gun assembly. DP mean deflection plate. FS mean fluorescent screen on CRT. GE mean glass envelope. This is the explain this one. So first to cathode ray tube. This is the cathode ray tube vacuum tube. This is the main function of the device, changes the signals in the electrical to visuals. So that is the main function of the electron gun you are using, that is generate the photons of the rays and speed up to high frequency. That is the horizontal rays moved electrons beams from the left side and to right side, left side to right side you change that. So this is the cathode ray tube. Next to the electronic gun assembly. This is also using the main function of the electronic gun is the emitting electronic to them into ray. The gun mainly include heater, a grid, cathode, anode and like accelerating and free accelerating and focusing. That is the main purpose of the using the electronic gun assembly. So next to deflection plate. This is the deflection plate is leaves the electronic gun. This ray will pass through the two set of the deflection plate. Two set of the deflection plate mean that is the vertical deflection plate and horizontal deflection plate, both values there. So that is the first one, H1 and H2 is there. So H1 and H2 are Y and X and Y is also change that one. So this is the, for example, deflection plate you are observe this. So you see this, okay. This is the vertical plates. Here is also horizontal plates, okay. This is the will be generate the vertical deflection, that is the known as the Y plates, the otherwise the vertical deflection plate. Next to the set of the plates use the horizontal deflection plates, which is known as the X plates, otherwise the horizontal deflection. Next to fluorescent screen of the CRT, fluorescent of CRT. So that is also same. This is screen your observation. CRO already this is the CRO. You see this is the deflection screen. This screen you are observe, this is the size is 100 mm into 100 mm, that is the screen. So you CRT, this is the 100 mm to 100 mm about this one. The CRT screen some bent the bigger displays and the formation of the face plate can be done by the pressing the melted glass, into the form of the after the heating this. So next to glass envelope. The glass envelope is inside the face of the CRT among the neck as well as display to cover through the aqua dot. That is conducting material that acts like a high voltage electrode. So this is the main point, this one. So next to working of CRO. The following the circuit diagram, the basic circuit of cathode ray oscilloscope. This is involves the discussed important part of the oscilloscope. This is you see internal block diagram of the CRO. So here already I am telling this. You have vertical amplifier. Here is also horizontal amplifier. Here external input. Vertical amplifier. This is the input signals. This delay line. This is the number of plates mean is the vertical plates and horizontal plates. The high voltage supply and low voltage supply. This is amplifier chip. So this is the trigger level mean trigger circuit. So first you see this one. This is the display. This is the output display. This is the internal display. Here is the internal display. Here is output display. You flow in this exactly. It depending on the plates. Deflection plates. This one. So this is the vertical plates. V mean vertical. H mean horizontal. Okay. E plates is a reflection rays. You go into this plates. You output you rays you are divided into this one. Here output waveform is came. So vertical deflection system. This is the main function of the amplifier. The weight signal that the amplifier signal produced by decide the signals. Okay. So, next the vertical deflection plates through the input and the number of amplifier stages. Next, horizontal is also same. Horizontal plates also deflection of the plates are the penetrated by the sweep voltage is given the time base. This is the discuss the 4 type of sweeps. 4 type of sweeps. This is here recurrent sweep, triggered sweep, driven sweep, non-sawtooth sweep. Okay. So, this is synchronization. Is synchronization done is to produce the stationary pattern. Stationary pattern. The synchronization between the sweep and signal should be measured. There are some source of the synchronization can be selected by the synchronization selectors, that is the internal and external and line. So, internal mean this signal measured of the vertical amplifier and the trigger obtain the signals. The external is the trigger should be present, that one. So, line triggered produced by the power supply. This is the line trigger mean produced by the power supply. Okay. So, this is also 2 types line signals, the intensity modulation and position in control. So, intensity modulation produced by inserting the signal between ground and cathode, intensity modulation signals between ground and cathode. The modulation traces the brightening of display. At the same time, positioning control, this by the small independent internal direct voltage source, the detecting plates through the potentiometer, the position can be controlled, and also we control the position of the signals. This also already discussed intensity control. This is the different changes in the grid potential the respect to the cathode rays. So, here the electronic quantities is the measurement is the 4 types. This is the electronic quantities is the 4 types, that is the CROs. That is the measurement of amplitude, measurement of the time period, measurement of the frequency. So, already you are discussed the measurement of the amplitude. Amplitude means your observation is the starting with the waveform. This one, this is the wave. Okay, this is the amplitude. Okay, your observation the amplitude this. Okay, this is the time period. This is the voltage. So, this is here the measurement of the amplitude, time period and the frequency. Here frequency is equal to T observed. That is the formula, actual formula. F is equal to T observed. T observed mean wavelength into time period. That is the T observed value. F is equal to 1 by T observed. That is the you are calculate the frequency. Okay. So, here this is the amplitude. CRO is the this one the voltage signal light the time function on the its display. Time function of the display, which is there are on the CRO screen with the help of the below formula. That formula is A is equal to J star NV. Here A is the amplitude, J is the volt for division value, and NV is the partition that cover upon the signal value, signal within the vertical value. Okay, na? So, this is the measurement of amplitude. Next to measurement of time period. This is also same. The measurement of time period, the voltage signal is constant, but we can vary the number of divisions cover the complete the circle. The circle means wave, that is you are observe the wave. Okay. The voltage signal in the horizontal direction of the varying time for division knob on the CRO panel. So, for example, is this one once again here CRO you look at this one. This is the time for division is a knob. Okay. You change this buttons is our observation, here is a wave, this one is for example is a wave is same here. This point to this point your time for division is that is the time period. So, this is also formula T is equal to KNH. So, here T is the time period, K is the time for division value, the N value is number of partitions of that is the cover value, the whole cycle of the periodic signal. So, next to measurement of the frequency. Measurement of the frequency of the tail, the frequency can be done very simple of the throw on the horizontal scale. You value time for divisions. Time for divisions also this is frequency f is equal to small f is equal to 1 by t observed. Okay, 1 by t observed. That is also here, this is the formula, given the formula, this is the f is equal to 1 by t, t means t observed value. So next to power supply, this is the given the power supply voltage required to the cathode ray tube, the generate and accelerate to electron beam, the cathode ray tube CRT, the requires high voltage for free accelerating and accelerating anode, low voltage required for heater controller, the vertical amplifier. That signal analysis of the apply to the vertical deflection waveform. So this is the trigger circuit. Exactly, this is the trigger circuit mean wave is for example blinking. Wave is for example is a blinking, exactly coincides the x axis and y axis exactly coincides the trigger button is constant value coincides exactly 0. That is the trigger circuit, this one. That is the triggered by the portion of the vertical amplifier output. Okay, the circuit initiates the time based generator that is linked between the vertical input and horizontal time base. Okay, the trigger circuit used the synchronize the horizontal deflection with the vertical deflection. Okay, so this is, you see, this is a vertical electrode and horizontal electrode. Here is also CRT, this is the electron beam. Here is also horizontal plates, here also vertical plates. This is the connection pins, mean CRO you connected, this is the CRO outside, they are connected the pins, CRO connected the pins. Okay, this is the electronic gun. Okay, so this one trigger circuit and power supply internal circuit. So this is the deflection system. This is the deflection system in here, the where the rays is deflection there. Here screen with the phosphorus, this one, this screen is the phosphorus plate. So here electrostats deflection system. Deflection system is two types. One is a electrostatic deflection on the electron beam in the used the general purpose oscilloscope. The deflected system consists of the pair of horizontal and vertical deflection plates, that is the considered two parallel vertical deflecting, that parallel vertical deflecting plates, that is the P1 and P2. That is a beam focused at the point origin 0 on the screen in the observers of the deflecting plates, that is P1 and P2. Okay, P1 and P2, that is P1 and P2 mean this is the P1, this is the P2. Okay, this is the vertical deflection plates, this is P1 and P2. Here positive voltage is applied to the plates P1 with the respect to plate P2. In negativity, the charged electrons are attracted towards the positive plates P1, positive plates is the P1. These are electrons will come to focus at the point Y1 on the fluorescent screen. So that is, this is the Y1. Okay, this is the focus in the, this one is here the Y1, another one is Y2. In middle value is origin value, rays of the, this is the reflecting plates, this one P1 and P2. So second one is deflection system 2. This is deflecting beam horizontally. First one is vertically, second one is horizontally. So this is the alternative voltage applied the horizontal deflecting plates on the spot of the screen horizontally. The electrons will focus on the H2 by changing the polarity of voltage. By polarity of the voltage, the beam is the focus point H1, that is the horizontal movement of the controlled along with the H1 and H2. This is also, you see the diagram. So here H1 and H2, here is also this is the H1 and H2. First one is here Y1 and Y2, second deflection plate, this one system is H1 and H2. Okay, this is the both deflection 1 and this is the deflection 1, another one is deflection 2. This diagram is both is different there. So next to, you see, this is the waveform. This is the screen. This is the screen. Your observer is the this is the vertical plates. Your vertical plates are wave form of the waves. This one here. The total is, this is the positive cycle is 180 degrees. 0 A B 0 A B. Here B, C, D. This is the one cycle. This is the one cycle is one total is a 360 degrees angle. So this wave is going to this screen. Your output is this is the waveform. This is the sine wave, for example, this is sine wave. Okay. So you see this one here is also same. Here 0, A, B and B, C, D. Okay. So this is the wave is a sinusoidal wave. Okay. So this is the input applied to the. So this is the waveform. So this is the depending on the same time for time based generator, and this is already I am telling that one. This is also waveform, also sawtooth voltage waveform. This is the square waveform. This one sweep time this, and flyback time this, at time is waveform. This is the different is given this one. So next type of the cathode ray oscilloscope is 4 type of cathode ray oscilloscope: analog CRO, digital CRO, storage CRO and dual beam CRO. So next application of the CRO. These CRO are used the hand application, light radio station for the observation, the transmitting and receiving the properties of the signals. So the CRO used to measure the voltage, current, frequency, inductance, resistance and power factors. So at the same time you are checking this is the CRO, your amplitude modulation and frequency modulation. Next they are using the comparing the phase and frequency modulations. That is, for example, you are using TV, radar and analysis of the engine as the pressures that is using. Reactions is the nerves and the heartbeat is also checking, this one you are using. At the same time loops and the high BP are also you checking this one. Next uses of CRO. This is the CRO, your uses of CRO, your lab, you are using the CRO laboratory. Use the can be displayed different type of the waveforms, that is the voltmeters, measure the potential difference. The advantage of CROs. Next disadvantage of CRO already you have given some point there. Yeah, thank you.